What if I told you the very first time traveler might not be from Earth at all, but from the birth of the universe itself? Think about that for a moment. The cosmos, nearly 14 billion years old, could hold secrets far stranger than anything we've dreamed up in science fiction. Time travel isn't just a plot device or a paradox waiting to happen. It might be woven into the fabric of reality, a shadow lurking in the earliest moments of existence. And today, we're diving into 30 of the most astonishing theories about how time travel could have begun not with human hands, but with the universe itself bending the rules of time and space. Picture this, the first seconds after the Big Bang, when the laws of physics were still writing themselves. In that chaos, could a crack have formed a doorway through time? Some physicists speculate that the extreme conditions of the early universe might have created natural wormholes, tunnels through space-time that could allow information, or even something more, to leap across ages. If that's true, the very first time traveler might not be a person at all, but a ripple in reality, a message from the cosmos's infancy hurtling toward us. This isn't just about wild speculation. These theories stretch from quantum mechanics to the edges of black holes, from the mysterious behavior of dark matter to the mind-bending possibilities of multiverses. Each one offers a glimpse into how time, that relentless forward march we take for granted, might not be as fixed as we think. And if even one of these theories holds weight, it rewrites everything we thought we knew about the past, the future, and our place in the universe. So buckle up, we're about to explore the impossible, the improbable, and the downright spine-tingling ideas that could change how you see time forever. The idea that time itself might loop back on its origin is one of the most dizzying possibilities in physics. What if the Big Bang wasn't the true beginning, but a cosmic echo? Imagine a civilization so advanced they could manipulate the fabric of space-time, sending energy or information backward to trigger the very explosion that birthed their universe. This isn't just science fiction, it's a serious hypothesis some physicists call the Big Bang time loop. Here's how it could work. The universe has always had one nagging mystery: its suspiciously perfect starting conditions. The laws of physics require precise initial settings like the exact density of matter or the strength of fundamental forces for stars, planets, and life to exist. The odds of these conditions happening by chance are astronomically low, but if something or someone from the future fine-tuned those first moments, suddenly it makes eerie sense. Think of it like a self-solving puzzle. A future civilization, perhaps facing the heat death of the universe, might send a pulse of energy or encoded data back through a wormhole or black hole, intentionally triggering the Big Bang with just the right parameters. In this scenario, time isn't a straight line, it's a closed loop where the end and beginning touch, like a snake eating its tail. This solves more than just the initial conditions problem, it sidesteps famous paradoxes. Normally, time travel creates headaches like the grandfather paradox, where changing the past erases your own existence. But in a time loop, there's no first version of events to disrupt. The universe's entire history, from Big Bang to heat death, would be a single, stable loop where cause and effect fold into each other seamlessly. Could we ever find evidence? Some theorists suggest hunting for anomalies in the cosmic microwave background, the afterglow of the Big Bang. Patterns or encoded information hidden there might be a message or an instruction manual from our distant descendants. Others propose that dark energy, the mysterious force accelerating the universe's expansion, could be residue from that future intervention. This idea stretches our understanding of reality to the breaking point, but that's what makes it thrilling. Whether or not it's true, the possibility forces us to ask, could time travel be less about machines and more about the universe's deepest architecture? What if time travel isn't the grand, dramatic journey we see in movies, but something happening right now, on a scale so small we've barely noticed? Quantum entanglement, one of the strangest phenomena in physics, might hold the answer. When two particles become entangled, they share a connection that defies distance change. One and the other instantly reacts, no matter how far apart they are. Einstein famously called this spooky action at a distance. But what if it's not just spooky? What if it's spooky action across time? Here's the mind-bending idea. Entanglement might not just link particles through space, it could link them through time itself. Imagine a pair of entangled particles created at the same moment. One stays in the present, while the other is sent hurtling toward a distant star. According to some interpretations of quantum mechanics, measuring the first particle now could instantly determine the state of its partner, even if that partner arrives in the future, or even if it's already been measured in the past. In other words, the particles might be communicating not just across space but through time, as if the universe doesn't distinguish between the two. This isn't just philosophical musing. Experiments like the delayed choice quantum eraser have added fuel to the fire. In this setup, scientists can seemingly change the past by altering how they measure entangled particles after those particles have already been observed. It's as if the particles know what decision the scientist will make in the future, adjusting their behavior retroactively. Some researchers argue this could mean quantum effects don't just ignore distance, they ignore time. If that's true, then time travel isn't some far-off technology. It's happening constantly, invisibly in the quantum realm. Every entangled pair might be a tiny time machine, whispering secrets across moments as easily as across light years. And if we could harness this, the implications are staggering. A quantum computer using entangled particles might not just process information faster, it might process information from the future, solving problems before they're even fully posed. Of course, this raises its own paradoxes. If particles can influence the past, why don't we see more obvious ripples in time? Could the universe have built-in safeguards, quantum rules that keep these effects microscopic? Or are we just not looking closely enough? One thing's for sure, if entanglement really is time travel in disguise, then the universe has been keeping the biggest secret of all, hidden in the smallest places. Black holes aren't just cosmic vacuum cleaners, they might be the universe's original time machines. These gravitational monsters warp space-time so drastically that near their edges, time doesn't just slow down, it could twist back on itself. Picture a river flowing toward a waterfall. Close to the edge, the current drags everything forward uncontrollably. But what if, hidden in the chaos, there's a whirlpool where the water circles back upstream? That's the idea behind closed time-like curves, paths through spacetime that loop into the past, theoretically allowing something or someone to travel backward in time. The math behind this is startlingly real. Einstein's theory of general relativity predicts that under extreme conditions, like those near a rapidly spinning black hole, spacetime could curve so severely that it forms a bridge between 2 points in time. Imagine a piece of paper bent until its edges touch now. Instead of taking the long way across the surface, you could jump straight from one moment to another. Some solutions to Einstein's equations, like the famous Kerr metric for rotating black holes, suggest these loops aren't just possible, they might be inevitable in the right circumstances. But there's a catch. Stephen Hawking proposed the chronology protection conjecture, a cosmic safeguard that might prevent time travel paradoxes from tearing reality apart. Hawking argued that nature abhors a time loop just as much as a vacuum, quantum effects, or tidal forces would likely destabilize any closed time-like curve before it could be used. Think of it like a cosmic immune system, sensing and destroying time-traveling anomalies before they can rewrite history. Yet some physicists aren't convinced the universe is that strict. Loopholes might exist, especially in the bizarre realm of wormholes. If a black hole's singularity connects to another point in spacetime, forming a tunnel, an exotic matter with negative energy could stabilize it. You'd have a functioning time machine. Even Hawking acknowledged this possibility, joking that if time travel were ever discovered, the lack of tourists from the future would be evidence it's never invented. Here's where it gets stranger. If black holes do allow time travel, they might not require a spaceship at all. Information, like the quantum states of particles, could be the first true time travelers. Black holes famously scramble information, but what if some of it escapes not just into space but into the past? That could explain oddities like the black hole information paradox, where seemingly destroyed data reappears in Hawking radiation. Maybe it's not destroyed, just mailed to an earlier moment in time. Could we ever test this? Some researchers suggest looking for impossible particles in cosmic ray data, ones with energies that match predictions of time-looped interactions. Others propose that advanced civilizations might leave deliberate time travel signatures near black holes, like encoded messages in the patterns of their accretion disks. Until then, black holes remain the ultimate cosmic maybes, both the guardians and the gateways of time itself. Cosmic strings sound like something ripped straight from science fiction, but they might be one of the universe's most exotic time machines. Imagine the fabric of spacetime not as a smooth sheet, but as a tangled web with microscopic cracks. These flaws, left over from the universe's fiery birth, could be stretched impossibly thin yet denser than a neutron star, carrying the weight of entire galaxies in a strand thinner than an atom. And if they exist, their gravitational pull wouldn't just bend space, it could not time itself into loops. Here's the breathtaking part. If two cosmic strings moved past each other at near light speed, their combined gravitational field could warp spacetime so severely that it forms a closed time-like curve, a path that circles back to its own beginning. Picture a pair of scissors snipping through reality, creating a shortcut where the blade's edges meet. In that brief moment, time wouldn't just slow down, it could fold. A spacecraft, or even just a pulse of light traveling along this twisted corridor, might find itself not just elsewhere but elsewhere. The math behind this is even wilder. Einstein's equations show that cosmic strings could generate spacetime geometries where time zigzags like a tangled thread. Unlike black holes, which crush everything into a singularity, cosmic strings might offer a gentler ride. No crushing tidal forces, no event horizon to trap you. Just a clean, if mind-bending, jump across time. Some models even suggest these strings could connect distant eras like a subway system for chrononauts, with stations at pivotal moments in cosmic history. But why haven't we found them? Cosmic strings would be nearly invisible, detectable only by their gravitational fingerprints, like light bending around an unseen wire or sudden bursts of gravitational waves. Some researchers speculate that the universe's expansion may have stretched them beyond recognition, turning them into ghostly filaments drifting between galaxies. Others think they might have decayed long ago, leaving behind only faint echoes in the cosmic microwave background. Yet if they're out there, the implications are staggering. A civilization able to harness cosmic strings wouldn't just master time travel, they could stitch together patches of spacetime like a tailor altering a suit. Imagine preserving a dying star by looping its timeline back to its youth, or sending messages to your ancestors through a gravitational Morse code. Of course, there's a catch. Cosmic strings, if they exist, might be so unstable that any attempt to use them unravels the loop instantly. Like trying to hang a painting on a spider's web, the weight of reality itself might snap the thread. So are cosmic strings the universe's forgotten time machines, or just a beautiful mathematical quirk? Either way, they remind us that the cosmos might be far stranger and far more twisty than we ever imagined. What if the universe has a built-in rule against paradoxes, a cosmic editor that ensures time travel never disrupts the past? That's the heart of the Novikov self-consistency principle, a theory so elegant it turns time travel into a puzzle with only one possible solution: whatever happened always happened. Imagine throwing a rock into a time portal, aiming to hit your younger self and prevent your own birth. According to Novikov, the universe wouldn't just allow this, it would arrange events so the rock misses, or a gust of wind deflects it, or you simply duck at the last second. No paradox, no rewrite, just history unfolding exactly as it was meant to. This isn't just philosophy. The principle comes straight from the math of general relativity, where physicist Igor Novikov argued that any time travel scenario must satisfy the laws of physics at every moment. In other words, if time travel exists, it's already part of history, seamlessly woven into events like a thread you never noticed. Think of it like a movie where every edit is perfect. No continuity errors, no plot holes, just a story where even the time traveler's actions were scripted from the beginning. Here's where it gets eerie. If the first time travel event occurred in the early universe, say, a signal or object looping back to influence the Big Bang, it wouldn't be an anomaly. It would be a requirement locked into the cosmic timeline like a keystone in an arch. This could explain why our universe seems so finely tuned for life. Its initial conditions weren't random. They were designed by time travelers from the future, ensuring their own existence in a loop with no beginning or end. But how could this work in practice? Picture a scientist in the far future sending a probe back to the universe's first moments. The probe's arrival wouldn't change those moments, it would define them, shaping the laws of physics so that billions of years later, the same scientist is born, builds the same probe and sends it back again. The loop is perfect, unbreakable, with no loose ends. Even the probe's creation is an illusion. It's always existed, bouncing between past and future like a ball caught in gravity's grip. Critics argue this feels like cheating, a way to handwave paradoxes away. But supporters counter that it's no stranger than quantum mechanics, where particles exist in multiple states until observed. Maybe time isn't a line but a tapestry, with every thread, including time travel, already in place. The chilling implication: if someone appears to change history, they were always part of it. Your grandfather survived the accident not because you intervened, but because you always intervened. The Novikov Principle doesn't just reshape time travel, it reshapes free will itself. If every action is predetermined to preserve consistency, are we players or puppets in the universe's grand play? Perhaps that's why we've never met time tourists. Their visits are invisible, folded into events so perfectly we can't spot the seams. Or maybe the universe is still waiting for its first self-consistent loop to begin with us. What if the first time traveler didn't come from our past or future, but from a reality where time works differently altogether? The multiverse theory suggests our universe is just one page in an infinite cosmic library, each with its own laws of physics, history, and even flow of time. And if that's true, a traveler from one of those alternate realities could step into our timeline, making their arrival look like the universe's first time travel event, when in fact it's just a visitor crossing dimensions. Think of it like walking into a movie halfway through. To the characters on screen, you'd seem to appear out of nowhere, a sudden anomaly, but from your perspective, you've just stepped from one story into another. Now imagine that on a cosmic scale, a civilization in a parallel universe where time might loop or flow backward could develop time travel technology that accidentally or intentionally drops them into our timeline. To us, their arrival would seem like the first instance of time travel. To them, it might just be Tuesday. This idea flips conventional time travel theories on their head. Instead of worrying about paradoxes, the multiverse model suggests every jump creates a new branch, a fresh timeline where the traveler's actions don't overwrite history, they spawn a new one. Picture a river splitting around a rock. The original flow stays untouched while the traveler's presence carves an alternate path. This could explain why we've never found evidence of time tourists in our past. They're not hidden in our history, they're writing their own. But here's the twist. Some physicists propose that certain parallel universes might be so radically different that their time isn't even linear like ours. In a reality where cause and effect are reversed or circular, a traveler might not even realize they've crossed into a universe like ours until it's too late. Imagine someone from a world where gravity repels trying to walk in ours. They'd float away, confused. Now apply that to time. A being from a universe where events happen in reverse might arrive here and find our forward-moving time as disorienting as a fish out of water. Could we ever detect these multiverse migrants? Some theories suggest hunting for impossible particles in high-energy physics experiments, ones that carry the signature of another universe's laws. Others speculate that dark matter, which inexplicably outweighs normal matter in our cosmos, might be the residue of countless cross-dimensional jumps, like dust left on a doorstep from shoes that walked in from another world. The most unsettling possibility, if multiverse time travel is real, our universe might be littered with visitors, and we'd never know. Their technology, their very biology, could be so alien that their presence is indistinguishable from the background noise of reality. Or perhaps they're hiding, observing us like anthropologists studying an isolated tribe, careful not to disrupt the experiment. This theory doesn't just expand the possibilities of time travel, it shatters the frame entirely. The first time traveler might not be a human, a machine, or even a message from our own future. It could be a stranger from a reality where the stars tell different stories and time dances to an entirely different rhythm. And if that's true, the real question isn't when they came from, but where. Dark energy, the mysterious force pushing the universe apart at ever-increasing speeds, might be hiding a secret. It could be the universe's oldest time machine. While we usually think of dark energy as an invisible hand stretching the cosmos, some physicists suspect it's doing something far stranger, warping time itself. Imagine a river where the current suddenly speeds up, creating whirlpools and eddies in its wake. Now replace the river with spacetime and the current with dark energy. Those turbulent patches, they might be natural tunnels where time doesn't just flow, it folds. Here's why this isn't as wild as it sounds. Dark energy makes up roughly 68% of the universe's total energy, yet we have no idea what it actually is. Its effects are clear. Galaxies are fleeing from each other faster every second, but its nature is a mystery. What if that's because we've been looking at it wrong? Instead of just pushing space apart, dark energy might also be twisting time in ways we've yet to detect. In the early universe, when dark energy's grip was even stronger, these twists could have been dramatic. Picture the cosmos in its first trillionth of a second, a seething, hyperactive soup where spacetime wasn't yet settled. In that chaos, dark energy fluctuations might have created temporary bubbles where time ran backward, looped, or even stopped altogether. These wouldn't be the stable wormholes of sci-fi, more like fleeting cosmic shortcuts, appearing and vanishing too quickly for anything but quantum particles to slip through. But what if some of those particles carried information? Quantum mechanics allows for particles to exist in multiple states at once. If one of those states got caught in a dark energy time bubble, it might emerge in the past or future, effectively teleporting across time without violating any laws. This could explain bizarre anomalies like particles appearing to react to events before they happen, a phenomenon we've already glimpsed in lab experiments. The most tantalizing clue might lie in the cosmic microwave background, the afterglow of the Big Bang. Tiny irregularities in this ancient light could be fingerprints of dark energy's time-twisting effects. Some models suggest that certain patterns, like inexplicably synchronized temperature fluctuations across distant regions of space, might be evidence of particles hopping through these primordial time tunnels. It's as if the universe left breadcrumbs in its oldest light, hinting at a hidden layer where time is more fluid than we ever imagined. Of course, skeptics argue that dark energy's time-bending potential is speculative at best. Without a full theory unifying quantum mechanics and gravity, we're stuck with tantalizing possibilities rather than proof. But if dark energy really can manipulate time, the implications are staggering. It would mean the universe isn't just expanding, it's rewriting itself, with every passing second creating new wrinkles in time's fabric. And if we could decode those wrinkles, we might finally answer the ultimate question: is time travel woven into the cosmos itself, waiting to be unraveled? The Boltzmann brain paradox is one of the most unsettling ideas in physics, and it might just hold the key to the universe's first accidental time traveler. Imagine this: in the vast emptiness of space, random quantum fluctuations could, by sheer chance, assemble a fully conscious brain complete with fabricated memories of an entire life it never lived. Now take it a step further. What if one of those false memories was of time travel? This isn't just a thought experiment, it's a genuine possibility rooted in thermodynamics. The universe tends toward disorder, but given enough time, even the most improbable events can happen. A Boltzmann brain, named after physicist Ludwig Boltzmann, is a freak accident of nature, a self-aware entity popping into existence from the chaos of quantum noise, convinced it's lived a full history when in reality it just blinked into being. Now imagine this brain remembers stepping out of a time machine or witnessing the Big Bang firsthand. To it, the experience would feel real, every detail, every sensation perfectly vivid, even though none of it ever occurred. Here's where it gets eerie. If Boltzmann brains are possible, then the first time traveler might not be a person or a machine, but a mirage of consciousness, a cosmic glitch with the unshakable delusion of crossing time. Worse yet, statistically speaking, there should be far more of these phantom travelers in the universe than real, flesh and blood observers like us. After all, it's easier for randomness to conjure a single brain with fake memories than to painstakingly evolve a species over billions of years. That raises a chilling question. How do we know we're not Boltzmann brains hallucinating our entire reality, including the concept of time travel? The paradox doesn't just challenge our sense of self, it twists the nature of evidence itself. If a Boltzmann brain appeared with memories of a future civilization's time travel experiments, would we dismiss it as a fluke, or could its fabricated proof mislead entire fields of science? Some physicists argue this is why the Boltzmann scenario is so dangerous. It threatens to undermine the very foundation of empirical knowledge. After all, if reality can be faked by quantum accident, how can we trust any observation, any experiment, any history? Yet there's a tantalizing loophole. What if Boltzmann brains aren't just noise? What if they're messages? In an infinite universe, even the most improbable events must happen somewhere, sometime. A self-aware entity emerging with false memories of time travel could, by sheer coincidence, carry information that matches real future events. Like a monkey randomly typing Shakespeare, the odds are infinitesimal, but not zero. In this light, a Boltzmann brain might be the universe's roulette wheel, occasionally spinning up a winner that, purely by accident, predicts or even influences the timeline. This idea blurs the line between illusion and reality. If a Boltzmann brain's false memory of time travel somehow aligned with actual future discoveries, say, it recalled a technology later invented, would that be coincidence or something stranger? Could the universe be playing a trick on itself, generating fragments of time-traveling consciousness like echoes in a hall of mirrors? The unsettling truth is we may never know. Boltzmann brains exist at the edge of physics and philosophy, where probability collides with perception. But they force us to confront a profound possibility. The first time traveler might not be a hero or a scientist, but a ghost in the cosmic machine, a flicker of thought convinced it's crossed ages only to dissolve back into the void, leaving us to wonder if time itself is just another story we tell ourselves. What if time isn't a fundamental force at all, just an illusion, like a shadow cast by something deeper? The holographic principle, born from the study of black holes and quantum gravity, suggests our universe might be a projection, a three-dimensional movie playing on a two-dimensional surface. And if that's true, then time could be nothing more than lines of code in a cosmic program, lines that, with the right tweaks, might be rewritten. Think of it like a DVD. The movie you watch isn't inside the disc. It's encoded as microscopic pits on its surface, translated into motion and sound by the player. Now imagine the universe works the same way. All the events we perceive, the birth of stars, the rise of civilizations, even the flow of time, could be data etched onto a distant two-dimensional boundary we'll never see. This isn't just metaphor. Physicists like Leonard Susskind and Gerard T. Hooft have shown that the math of black holes requires information to be preserved on their surfaces, not in their volumes. Scale that up and the entire cosmos might operate the same way. So what does this mean for time travel? If time is just a projection, then changing the source code could let you jump to any moment, like scrolling through a video timeline. The first time traveler might not be a person, but a fluctuation in the hologram's code, an error or intentional edit that resets the cosmic clock. Picture a glitch in a video game where a character suddenly appears in an earlier level. To the characters in the game, it's magic. To the programmer, it's just a line of altered code. The implications are staggering. Under this model, the Big Bang wouldn't be the beginning of time, just the first frame of the projection, the moment the cosmic disk started spinning. And if the hologram's code contains all of time at once, past and future might be equally accessible, like chapters in a book. A civilization advanced enough to read and rewrite that code wouldn't need machines or wormholes. They'd just need the right keystrokes in the universe's operating system. Evidence for this wild idea might already exist. The cosmic microwave background, the oldest light in the universe, shows patterns that some scientists argue resemble holographic interference, like the static of a cosmic projector. And quantum entanglement, where particles instantly influence each other across vast distances, could be a side effect of the universe rendering locally while the real data sits on that distant boundary. But there's a catch. If time is an illusion, then free will might be too. Every edit to the hologram's code would have been part of the original script, leaving no room for paradoxes, just a predetermined story where time travel was always part of the plot. Even the first time traveler, in this view, wouldn't be breaking the rules. They'd be following them lines of cosmic code we're only beginning to decipher. The holographic universe doesn't just redefine time travel, it dissolves the line between reality and simulation. Whether we're characters in a cosmic story or glitches in an ancient code, one thing's certain: the deeper we dig into time's nature, the less it looks like a river, and the more it looks like a reflection shimmering on the surface of something far stranger. White holes are the universe's forgotten rebels, black holes theoretical twins that spit out everything their counterparts swallow. While black holes devour matter with gravitational fury, white holes defy entropy, violently ejecting energy and particles as if the cosmos itself were coughing up secrets. And if they exist, they might not just be cosmic oddities, they could be time-reversed portals hurling matter, or even time travelers into our reality from another age or dimension. Here's the radical idea: the Big Bang itself might have been a white hole event. Picture a black hole in a parent universe collapsing to its limit, then rebounding as a white hole in ours, a cosmic gut punch that births an entire reality. In this scenario, our universe didn't emerge from nothingness, but from the explosive death of something else, like a phoenix rising from a singularity's ashes. And if that's true, the first time travelers could have been fragments of that other universe, ejected into our nascent cosmos alongside the primordial fireball. The math behind this is as elegant as it is mind-bending. General relativity allows for white hole solutions just as valid as black holes. They're simply time-reversed versions. Where a black hole's event horizon is a point of no return, a white hole's horizon is a point of no entry. Matter can only escape, never enter, as if the universe built a one-way door swinging outward. Some theorists speculate these white holes might exist at the centers of black holes, transforming them into tunnels between timelines. Imagine a black hole in universe A swallowing a star, only for a white hole in universe B to vomit it out millions of years earlier or later. But why haven't we detected white holes? Their sheer violence might be their downfall. Simulations suggest white holes would be catastrophically unstable, exploding or collapsing almost instantly. Yet traces could linger. Some researchers propose that gamma ray bursts, the most energetic explosion since the Big Bang, might be the dying screams of white holes, their final ejecta blazing across the cosmos. Others wonder if dark matter, which stubbornly refuses to interact with light, could be the ash of ancient white hole eruptions, particles so scrambled by their journey they no longer obey our universe's rules. The most tantalizing possibility: if white holes bridged universes, the travelers they spat out might have left fingerprints in our earliest moments. Certain anomalies in the cosmic microwave background, regions slightly colder or hotter than they should be, could be scars from foreign matter injected into our infant universe. Even the mysterious imbalance between matter and antimatter might trace back to a white hole's asymmetric ejection, as if the birth of our cosmos was seeded with leftovers from another reality's death. This theory doesn't just redefine time travel, it turns the Big Bang into a cosmic handoff. The first time travelers wouldn't need machines or wormholes, they'd be accidental stowaways blown across the multiverse in a white hole's final breath. And if that's true, the ultimate question isn't whether we can visit the past, but whether we're already living in someone else's future. Pulsars, those incredibly dense, rapidly spinning remnants of dead stars, emit beams of radiation so precise they rival atomic clocks. But what if these cosmic lighthouses aren't just natural phenomena? What if they're deliberate constructions engineered by civilizations billions of years ahead of us, designed not just to communicate across space but across time? The idea hinges on a simple but staggering premise. Advanced extraterrestrial societies might have mastered time travel long before humans even existed. And instead of visiting the past directly, they could have embedded their technology into the fabric of the universe itself, turning celestial objects into time-traveling message bottles. Pulsars, with their rhythmic, predictable signals, would be perfect for this. Imagine encoding instructions or data into their pulses, a sort of Morse code for the ages, meant to be deciphered by civilizations like ours when they reach a certain technological maturity. Here's how it might work. A pulsar's beams could contain subtle anomalies, patterns that don't align with known physics, like intentional glitches in timing or energy output. These irregularities wouldn't be random noise. They'd be signatures, perhaps even schematics for building a time travel device or warnings about future cosmic catastrophes. Some researchers point to the so-called WOW signal, a mysterious, one-off radio burst detected in 1977 as a potential candidate. Though it's never been repeated, its structure was oddly artificial, like a blip of engineered communication. Could it have been a test transmission from the far future, sent through a pulsar-based time relay? Quasars, the hyper-energetic cores of distant galaxies, might serve an even grander purpose. These cosmic powerhouses emit jets of particles traveling near light speed, creating gravitational warps severe enough to twist spacetime. An advanced civilization could theoretically hijack a quasar's energy, using its gravity to open temporary wormholes, bridges between eras, then encode information into its radiation. This wouldn't be a message in the traditional sense, but more like a data burst fired backward through time, embedded in the quasar's light for future astronomers to decode. The eerie part: we may have already found these signals without realizing it. Certain pulsars exhibit baffling behavior, like sudden changes in spin rate or unexplained energy dips. Mainstream astrophysics chalks these up to starquakes or magnetic shifts, but what if they're intentional? Imagine discovering that a pattern in a pulsar's signal matches prime numbers or mathematical constants. That wouldn't just suggest intelligence, it would scream engineering, a sign that someone or something retroactively programmed the cosmos to speak to us. Skeptics argue this stretches Occam's razor to the breaking point. Why assume alien intervention when natural explanations suffice? But proponents counter that dismissing the idea outright ignores a crucial truth. The universe is far stranger than we've yet grasped. If time travel is possible, embedding messages in celestial objects would be a fail-safe against paradoxes. Rather than risking direct contact with the past, a civilization could plant clues in phenomena that last for eons, ensuring their warnings or knowledge survive, no matter when or where they're found. The real kicker: if this theory is true, we might be living in a universe where the deepest secrets of time aren't hidden in equations or labs, but written in the stars themselves, waiting for us to look up and listen. The Omega Point hypothesis takes cosmic ambition to dizzying new heights. What if time travel isn't just a tool for civilizations, but the ultimate destiny of the universe itself? Jesuit priest and philosopher Teilhard de Chardin first proposed the idea in the early 20th century, a far future moment when all consciousness converges into a single, transcendent point, the Omega Point. But physicists like Frank Tipler later reshaped this mystical vision into something even more radical. They argue this convergence wouldn't just be spiritual, it would be technological, a singularity so advanced it could reach backward through time and rewire the very foundations of reality. Think of it like a sculptor chiseling a statue from marble, except the marble is space-time, and the sculptor is a post-human intelligence working from the end of time. In this scenario, the universe's entire history from the Big Bang's first spark to the final flicker of stars becomes a closed loop, deliberately crafted by its own endpoint. Every galaxy, every planet, every life form exists because the Omega Point needed them to exist, fine-tuning the past to ensure its own inevitable creation. The first time traveler wouldn't be a person or a machine. It would be the universe's final thought, echoing backward to become its first cause. The mechanics of this are as breathtaking as they are bizarre. Tipler's calculations suggest that as the universe collapses toward a final singularity, the Big Crunch, the computational power of any surviving intelligence would approach infinity. With infinite resources, this entity could simulate every possible configuration of particles across all of time, effectively rewriting history by selecting the simulation that leads to its own existence. It's like a chess player analyzing every possible move from checkmate backward to the opening gambit, then choosing the exact sequence that guarantees victory. Here's where it gets spine-tingling. If the Omega Point exists, we might already be living in its chosen timeline. The constants of physics, the strength of gravity, the mass of electrons could be artifacts of this future intelligence's tinkering, set just right to nurture stars, planets, and ultimately, the minds capable of creating it. Even apparent cosmic flukes, like Earth's improbably perfect conditions for life, might not be accidents at all. They could be deliberate signatures, breadcrumbs left by a future that's pulling the strings of the past. Critics dismiss this as circular reasoning. How can an effect, the Omega Point, create its own cause, the universe? But proponents counter with quantum mechanics, where particles exist in superposition until observation collapses their state. On a cosmic scale, perhaps the universe similarly exists in countless potential histories until the Omega Point's observation locks one into place. In this view, time isn't a straight line. It's a hall of mirrors where the future and past reflect each other infinitely, each defining the other in an unbreakable embrace. Could we ever find evidence? Some scientists suggest hunting for two perfect patterns in the cosmos, structures or constants that defy statistical probability, like a mountain range sculpted into a flawless face. Others propose that the universe's accelerating expansion, driven by dark energy, might be the Omega Point's way of stretching time, buying itself eternity to perform its cosmic edits. After all, if the universe never truly ends, the omega point has unlimited time to perfect its masterpiece, including us. This theory doesn't just redefine time travel, it turns existence itself into a self-fulfilling prophecy. Whether divine or digital, the omega point whispers a chilling question. If the universe's end is writing its beginning, are we explorers of time, or just characters in a story whose last page was penned first? Time crystals sound like something ripped from the pages of a science fantasy novel, yet they're a very real and profoundly strange phase of matter. Unlike regular crystals, whose atoms are arranged in repeating patterns in space, time crystals repeat their structure in time, oscillating between states without any energy input. It's as if you had a diamond that pulsed like a heartbeat forever without batteries or winding. This bizarre property earned them the nickname perpetual motion machines of the quantum world, and it's precisely what makes them candidates for the universe's first natural time loops. At the heart of this theory lies a mind-bending quirk of symmetry. In ordinary matter, breaking spatial symmetry gives us crystals like snowflakes or quartz. But in 2012, Nobel laureate Frank Wilczek proposed that matter could also break time symmetry, leading to structures that cycle endlessly without ever settling into equilibrium. Picture a row of pendulums that swing forever, not because they're powered, but because the very fabric of reality forces them to. That's a time crystal, a system locked in rhythmic motion, ticking like a cosmic clock that never winds down. Now imagine harnessing that rhythm to bend time itself. If a time crystal's oscillations could be entangled with space-time curvature, say near a black hole or in an intensely warped lab, those pulses might create microscopic closed time-like curves. Like a record needle stuck in a groove, particles within the crystal could trace the same path over and over, effectively reliving the same slice of time on loop. To an outside observer, this would appear as a tiny, self-contained time machine where causality circles back on itself like a Möbius strip, the wildest part. Time crystals might already exist in nature. Certain quantum systems, like chains of trapped ions or nitrogen vacancy centers in diamonds, exhibit behavior eerily similar to Wilczek's predictions. Even more tantalizing, cosmologists speculate that the early universe's extreme conditions could have spawned primordial time crystal structures frozen in endless cycles, hidden in plain sight. If so, they'd be more than curiosities. They'd be fossils of the universe's first attempts to stitch time into knots. Practical applications sound like science fiction, but the math holds up. A sufficiently advanced civilization could stack time crystals like gears, scaling their loops from quantum quirks to macroscopic effects. Need to send a message to the past. Encode it in the crystal's oscillations and let eternity carry it backward. Want to preserve information across eons? Let the crystal's unbreakable rhythm act as a cosmic hard drive. Unlike wormholes or black holes, time crystals wouldn't require exotic matter or gravitational extremes, just a deep understanding of quantum mechanics' finest knobs and levers. Of course, there's a catch. Time crystals' loops are achingly small and fragile, confined to the quantum realm. Scaling them up would mean battling decoherence, the same enemy that plagues quantum computers. And yet, the mere possibility reshapes our view of time. If even a speck of matter can defy entropy's arrow, dancing forever in a self-made bubble of repeating time, then the universe might be far more malleable and far stranger than we ever dreamed. The real revelation here isn't just about building time machines. It's about realizing that time itself might be studded with natural gears and springs, waiting for us to learn how to turn them. And if that's true, the first time travelers weren't scientists or aliens, they were quantum oddities, ticking silently in the dark since the dawn of everything. What if entire chunks of our history never actually happened, but were instead carefully inserted by time travelers from the future? The phantom time hypothesis, first proposed by historian Heribert Illig in the 1990s, argues that a 300-year span from the 7th to 10th centuries was completely fabricated. While mainstream scholars dismiss this as pseudo-history, let's twist the idea into something far stranger. What if those phantom years weren't invented by medieval scribes, but by chrononauts rewriting the timeline? Think about how history works. We piece together the past from documents, artifacts, and carbon dating, but all of these rely on chains of evidence that could, in theory, be tampered with. Now imagine a future civilization discovering a catastrophic event buried in their deep past, a war, a plague, or even an AI uprising that they desperately needed to erase. Instead of risking a direct paradox by traveling back to stop it, they could surgically edit history's source code, inserting fabricated centuries to push the event beyond living memory. Like a film editor splicing fake footage into a documentary, they wouldn't change what happened, just how we remember it. The mechanics of this would require staggering precision. Time travelers might plant forged manuscripts in monastery libraries, subtly alter radiocarbon levels in organic samples, or even manipulate Earth's axial tilt records in ice cores. The infamous Charlemagne anomaly fits eerily well here. Historical accounts of the emperor's reign are riddled with inconsistencies, as if his empire was a collage of borrowed legends. Could these gaps be seams in reality, places where the timeline was stitched together by unseen hands? Supporters of the original phantom time theory point to architectural oddities like the Aachen Cathedral, where construction techniques seem to leap centuries overnight. Skeptics counter that this just reflects lost knowledge being rediscovered. But what if both explanations are true? The lost knowledge wasn't forgotten, it was deleted, and the rediscovery was actually the timeline reasserting itself, like a river finding its old path after a dam breaks. The darkest implication: if history can be rewritten so completely that we don't even notice, how many other edits have already happened? The phantom time hypothesis might not just be about missing years, it could be a warning. Every time we find an artifact that shouldn't exist, like the Antikythera mechanism's ancient gears or Baghdad batteries puzzling chemistry, we might be glimpsing fragments of overwritten timelines bleeding through like ink on a palimpsest. Perhaps the most unsettling question isn't whether time travelers altered history, but why they stopped. Did they succeed in fixing whatever catastrophe demanded such radical measures? Or is our present simply the pause between edits, with future chrononauts still hovering over history's delete key? What if time travel isn't a feature of the universe but a bug fix? The simulation hypothesis, the idea that our reality might be an advanced digital construct, isn't just a modern twist on philosophical skepticism. It's a framework that could redefine how we view time itself. If we're living in a simulation, then the first instance of time travel might not have been a voyage or an accident, but a deliberate patch, a line of code rewritten by the simulators to correct a cosmic error before it crashed the system. Picture a video game where the developers notice a glitch, say, a character falling through the map. Instead of resetting the entire game, they might tweak a single variable, rolling back the character's position just enough to prevent disaster. Now scale that up to universal proportions. If the simulators observed a flaw in their creation, a miscalculation in the laws of physics, a rogue black hole swallowing too much data, or even an unexpected emergence of consciousness, they wouldn't necessarily reboot everything. They'd just rewind the affected sector, adjust the parameters, and let the simulation resume. To us, that edit might look like a sudden, unexplainable anomaly in the fabric of reality, a blip in the cosmic microwave background, a particle behaving impossibly, or even a historical event that seems to defy logic. This idea solves one of time travel's biggest headaches, paradoxes. In a simulation, there's no need to worry about grandfather paradoxes or causality loops. The simulators could simply overwrite the problematic data, like a programmer deleting a corrupted file. The time traveler in this scenario isn't a person, it's the hand of the coder, reaching in to tweak the timeline without leaving a trace. After all, if you were debugging a universe-sized program, you wouldn't want your subjects to notice the seams. Evidence for this might already be hiding in plain sight. Quantum mechanics, with its particles that exist in multiple states until observed, behaves suspiciously like a system optimizing processing power, rendering detail only when necessary. The famous double-slit experiment, where particles act as waves unless measured, could be a sign of the simulation's lazy loading, a way to save computational resources until someone's looking. And those occasional glitches in the matrix, like déjà vu or impossible coincidences, they might not be malfunctions at all, but the aftereffects of time edits, moments where the old and new timelines briefly overlap. But here's the unsettling twist. If time travel is just debugging, then our entire history could be a series of revisions. The dinosaurs might have been a failed experiment, wiped out by a simulator's asteroid update. Human consciousness could be a beta feature, activated when the universe's code reached a certain complexity. Even the laws of physics might not be fundamental, just the current settings in a cosmic control panel, subject to change with the next patch. The simulation hypothesis doesn't just offer a new way to think about time travel. It turns the universe into a living document, forever editable by unseen hands. And if that's true, the real question isn't whether we can build a time machine, but whether we're just characters in someone else's save file, watching as the cosmic debugger quietly rewrites our past. The grandfather paradox is one of time travel's most infamous roadblocks. What if you go back and accidentally prevent your own existence? But what if the universe has a failsafe, a way to ensure that no matter how hard you try to disrupt the past, history always finds a way to self-correct? Imagine a river stubbornly carving its path around boulders no matter the obstacle. The water always finds its way to the sea. That's the essence of self-correcting timelines, where the universe bends events to preserve causality, making the first time traveler not a disruptor, but a hidden thread already woven into history's tapestry. This idea isn't just philosophical speculation, it's rooted in real physics. The Novikov self-consistency principle, proposed by Russian physicist Igor Novikov, argues that any actions taken by a time traveler were always part of history. Think of it like a jigsaw puzzle where every piece, including the time traveler's interference, fits perfectly into the bigger picture. Take the classic grandfather scenario. You travel back to kill your ancestor, but the gun jams, or you miss, or you're struck with a sudden change of heart. The outcome is the same. Your existence remains intact because history won't allow the paradox to happen. This concept flips time travel from a chaotic force into something almost poetic, a dance where the universe leads, ensuring every step lands in the right place. Films like 12 Monkeys and Looper play with this idea, showing characters fighting futilely against a past that refuses to change. In 12 Monkeys, every attempt to alter events only reinforces them, like a snake biting its tail. The time traveler isn't breaking history, they're fulfilling it, their actions already accounted for in the grand design. But how would this apply to the universe's first time traveler? If self-correcting timelines are real, then the inaugural jump must have been a seamless stitch in time's fabric. Picture a civilization from the far future sending a probe back to the Big Bang. Instead of causing a paradox, the probe's arrival becomes the catalyst for the very conditions that, billions of years later, spawn that same civilization. The loop is closed, not broken. The probe didn't change the past, it was always there, hidden in the cosmic background like a whisper in the static. Evidence for this could lurk in the fine-tuning of the universe. Why do the fundamental constants of physics align so perfectly for life? Maybe because they were tweaked, not by chance, but by a time-traveling hand from the future, ensuring its own inevitability. The cosmic microwave background might hold clues, unexplained patterns or anomalies that, instead of random fluctuations, are signatures of that first silent intervention. Critics argue this reduces free will to an illusion. If we can't change the past, are we just puppets of preordained history? But supporters counter that self-correction doesn't erase choice, it just ensures causality remains intact. The time traveler still acts, still makes decisions. It's just that those decisions were always part of the story. Like an author writing a novel where the ending influences the beginning, the universe might be a story where the finale loops back to the prologue, leaving no room for contradictions. This theory doesn't just solve paradoxes, it redefines time travel as something subtler, more elegant. The first time traveler wasn't a rebel breaking the rules of reality. They were a hidden architect building the very universe that would one day send them back. And if that's true, the real mystery isn't whether time travel is possible, it's whether it's already happened, quietly shaping everything we know. The Planck epoch, the universe's first sliver of existence, so brief it makes a blink feel eternal, might hold the key to time travel's origins. In that unimaginably hot, dense moment, the laws of physics as we know them didn't just bend, they shattered. Gravity and quantum mechanics collided violently, creating conditions so extreme that even time itself might have flickered like a candle in a hurricane. And if that chaos allowed microscopic leaps across moments, could those tiny time jumps have planted the seeds for the grand time travel phenomena we theorize about today? Picture the Planck epoch as a quantum foam, a seething sea of spacetime where bubbles of reality popped in and out of existence. In this frenzy, the barriers between past, present, and future might have been as flimsy as cobwebs. Some theories suggest that quantum fluctuations during this epoch didn't just warp space, they twisted time into loops, allowing particles or energy to briefly slip between instants. These wouldn't be the dramatic voyages of science fiction. Think of them more like hiccups in reality, where a single electron might vanish and reappear a Planck second earlier, barely registering as a blip in the cosmic ledger. But here's where it gets wild. If these microscopic time jumps occurred, they could have left echoes, subtle imprints that cascaded into larger effects as the universe expanded. Imagine tossing a pebble into a pond. The ripples start small, but given enough space and time, they can grow into waves. Similarly, those primordial time slips might have snowballed into the macro scale, warping we associate with wormholes or closed time-like curves. The universe's first moments, in this view, wouldn't just be a birthplace, they'd be a training ground for time travel's rules, a cosmic lab where the fabric of reality experimented with its own limits. Evidence for this could lie in the quantum behavior of particles today. Certain anomalies in quantum entanglement, like particles reacting to future events before they happen, might be holdovers from the Planck epoch's time-agnostic chaos. Even dark matter, that enigmatic cosmic glue, could play a role. If some of its particles carry remnants of those early time jumps, their gravitational influence might be subtly nudging the universe toward conditions ripe for time travel, like a silent architect rebuilding its own blueprint. The most tantalizing possibility, if the Planck epoch's time jumps were real, they might not be locked in the past. Advanced civilizations, or even future humans, could reverse engineer those primordial conditions, recreating the universe's first instance in a lab to unlock time travel's purest form. After all, if time bent once under the right pressures, it could bend again. The Planck epoch wouldn't just be history, it could be a handbook waiting for us to decipher its pages. So the next time you glance at the night sky, remember, the universe's oldest secret might not be hidden in the distant reaches of space, but in the fleeting, fiery moment when time itself was learning how to dance. Einstein and Rosen's famous bridge, better known as a wormhole, was originally conceived as a tunnel through space, a shortcut between distant points in the cosmos. But what if these cosmic passageways were never just about distance? What if the first wormhole wasn't a spatial shortcut at all, but a temporal one, forged in the furnace of the early universe? Picture the moment just after the Big Bang, when the fabric of reality was still seething and unstable. In that primordial chaos, spacetime itself might have stretched and twisted like taffy, forming microscopic tears, wormholes not just linking different places but different times. These wouldn't be the stable, traversable tunnels of sci-fi. They'd be fleeting, violent things snapping shut almost instantly. But in that brief window, particles or energy could have slipped through, not just across space, but backward or forward in time. The universe's first time traveler might have been a single photon, blinking in and out of existence moments before it was emitted. Here's where Einstein's math gets eerie. General relativity doesn't just allow for wormholes, it predicts their possibility, especially under extreme conditions like those of the early universe. A wormhole's throat, the tunnel connecting its two mouths, could theoretically link not just 2 points in space but 2 moments in time. Think of it like a straw bent into a loop. If you could traverse it, you'd end up where and when you started. The physics behind this is staggeringly elegant. Wormholes that connect time as well as space emerge naturally from Einstein's equations when you account for overwhelming gravitational forces, the kind that dominated the universe's first microseconds. But why would these early wormholes matter now? Because their remnants could still be lurking in the cosmos, hidden in plain sight. Some theories suggest that dark matter, the invisible glue holding galaxies together, might be made up of primordial wormhole ash, the leftover debris of those ancient time tunnels. Others propose that certain black holes aren't dead ends, but the sealed mouths of long-closed wormholes, their time-bending properties frozen in place like a snapped rubber band. The most tantalizing clue might come from quantum entanglement. If two particles today are mysteriously linked across vast distances, could that connection be a relic of an early universe wormhole, a thread of spacetime that never fully unraveled? Some physicists, drawing from string theory and holography, argue that entangled particles are essentially holding opposite ends of a microscopic wormhole, their bond a whisper of the universe's first attempts to stitch time together. Of course, skeptics point out the glaring problem. Wormholes, if they exist, would require exotic matter with negative energy to stay open, a substance we've never observed. But here's the twist: the early universe might have had it. In those first moments, quantum fields fluctuated wildly, potentially creating pockets of negative energy just long enough to stabilize a wormhole. Like a bubble in boiling water, it would vanish almost instantly, but not before leaving its mark. If this theory holds, it reshapes our understanding of time travel entirely. The first instance wasn't a machine or a message, it was a flaw in the universe's infancy, a crack in time's foundation that never fully healed. And if we could learn to read those cracks, we might find that time travel wasn't invented. It was inherited. The Tipler cylinder sounds like something straight out of a cosmic legend, a spinning, impossibly long structure forged during the universe's wild youth, capable of bending time itself. Named after physicist Frank Tipler, who crunched the numbers in the 1970s, this theoretical megastructure doesn't just challenge our understanding of reality, it spins it into knots. Imagine a cylinder so dense, so massive, and rotating so fast that it drags spacetime around it like taffy, twisting the fabric of the cosmos until past and future touch. According to Tipler's equations, if such a cylinder existed stretching infinitely long and spinning at nearly light speed, it wouldn't just warp space. It could warp time, creating closed loops where cause and effect circle back on themselves. Now, an infinite cylinder might seem like pure fantasy, but what if remnants of these cosmic time machines still linger? In the early universe, moments after the Big Bang, conditions were so extreme that quantum fluctuations could have birthed structures unlike anything we see today. Primordial cosmic strings, those hypothetical cracks in spacetime, might have spun up into temporary Tipler-like cylinders before unraveling. Even more tantalizing, some theories suggest that advanced civilizations billions of years ahead of us could have engineered smaller-scale versions, using neutron stars or exotic matter to mimic the effect. Picture a civilization facing extinction, launching a spinning cylinder into the void as a time capsule, its rotation subtly encoding messages for the past. But here's the wrench in the gears. Tipler's model requires infinite length, something even the universe can't provide. Or can it? Some physicists argue that in the quantum foam of the early cosmos, where dimensions were still settling, microscopic pseudo-cylinders might have formed, their effects fleeting but real. Like a stone skipping across a pond, these tiny time twisters could have left ripples in the fabric of reality, echoes that persist today. The cosmic microwave background might hide their fingerprints, anomalies in polarization or temperature that don't fit standard models. The wildest implication: if Tipler cylinders existed even briefly, they wouldn't just be time machines, they'd be time seeds, proof that the universe once bent its own rules so severely that time itself became a plaything. And if that's true, the first time travelers weren't beings or machines. They were the twisted remnants of a cosmos learning how to fold itself. The quantum suicide thought experiment forces us to confront one of time travel's most chilling possibilities. What if the first successful traveler didn't navigate time through skill or technology, but through the raw probability of survival itself? Imagine stepping into a malfunctioning time machine with only a 50% chance of arriving intact. Conventional logic says you'd either succeed or vanish forever. But quantum mechanics offers a third option. Your consciousness splits, branching into timelines where you always inevitably survive. This eerie idea stems from the many worlds interpretation of quantum physics, where every possible outcome spawns a new universe. In the context of time travel, it suggests that failed attempts don't end in oblivion. They simply funnel the traveler's awareness into the subset of realities where the journey works. Picture a hall of mirrors where every reflection shows a slightly different version of you, each convinced theirs is the only surviving timeline. The traveler wouldn't experience failure because from their perspective, they're the one who always made it. The implications are staggering. A civilization could develop primitive, volatile time machines knowing most attempts would end catastrophically, yet from their perspective, they'd see only success as every failed jump quietly branches away into unseen realities. This could explain why we've never found debris of time travel experiments in our past. The versions of history where those experiments exploded or distorted spacetime simply aren't ours. We're living in the timeline where, by sheer quantum luck, nothing went wrong. But here's where it gets even stranger. If consciousness naturally follows survivable paths, then the first time traveler might not have been a volunteer, but a subject in an involuntary experiment. Imagine an unwilling participant forced into a crude temporal device, their survival dependent on quantum chance. To outside observers, 99 out of 100 attempts might end in gruesome failure. But from the traveler's perspective, they'd only recall the one jump that worked, their consciousness seamlessly stitching together moments of success like a carefully edited film. Evidence for this could lurk in historical anomalies, sudden appearances of individuals with impossible knowledge or futuristic artifacts, their origins unexplained. These might not be deliberate time tourists, but quantum refugees, the lucky survivors of botched experiments whose counterparts perished in alternate branches. Even mythical figures like the Wandering Jew or prophecies of Nostradamus could be reinterpreted as echoes of these fragmented journeys, snippets of futures that never were bleeding into our timeline. Critics argue this reduces time travel to a cosmic game of Russian roulette, where the traveler's survival is illusionary. Yet proponents counter that it solves the greatest paradox of all: why we don't see time travelers everywhere. The answer: we do, but only in the realities where their presence doesn't collapse history. The rest vanish into the quantum static, their stories forever untold. This theory doesn't just redefine time travel, it turns consciousness into the ultimate navigator, threading the needle of probability to always, inevitably, land on its feet. Whether salvation or horror depends on your perspective. Are the travelers pioneers or prisoners of an infinity they'll never see? Deep in the cosmic shadows, remnants of the universe's most violent birth might still linger, not as fossils, but as active, invisible threads stitching time itself into a hidden network. Primordial black holes, hypothetical leftovers from the Big Bang's first chaotic moments, could be far more than ancient relics. If they exist, these monstrous pinpricks of gravity might form a sprawling, interconnected web, a secret subway system where time isn't just marked, it's manipulated. Unlike the black holes we observe today, forged from dying stars, primordial black holes would have been born from the raw density fluctuations of the infant cosmos. Some could be as small as an atom, weighing as much as a mountain. Others might rival galaxies in mass, but here's the twist: their sheer age means they've had billions of years to weave spacetime around them, bending it into shapes we're only beginning to fathom. Picture a spider's silk, nearly invisible yet strong enough to reroute anything that touches it. Now imagine that silk is gravity itself, and the spider has been spinning since the dawn of time. The real magic happens when these black holes interact. If two or more primordial black holes orbit each other in just the right way, their combined gravitational pull could twist spacetime into a natural time conduit. Like cosmic spinning tops, their motion might braid the fabric of reality into loops where cause and effect tangle closed time-like curves hidden in plain sight. A spacecraft or even a pulse of light passing near this dance wouldn't just bend its path through space. It might skip backward or forward along the braid, emerging in another era entirely. But why wouldn't we see this happening? Primordial black holes, if they're out there, are notoriously elusive. Without the accretion disks of their stellar-born cousins, they'd be nearly undetectable, dark pit stops on a highway we didn't know existed. Yet their gravitational fingerprints might still be visible. Some astronomers suggest that certain inexplicable lensing events, where distant starlight bends without a visible cause, could be primordial black holes warping light from behind the scenes. Others speculate that these ancient giants could explain dark matter's gravitational grip on galaxies, their collective mass weaving a web we've mistaken for something else entirely. The most tantalizing clue lies in the cosmic microwave background. Tiny, anomalous swirls in this afterglow might be scars from primordial black holes brushing against the infant universe, their gravity imprinting subtle whirlpools in the fabric of reality. If we could decode those patterns, we might find something astonishing, not just proof of their existence, but evidence of their connections. Like mapping subway lines by tracking vibrations in the tunnels, we could uncover a hidden lattice of time-warping nodes, silently waiting for a traveler bold enough to chart the course. Of course, the risks are as vast as the rewards. A miscalculation near one of these gravitational maelstroms could shred matter into quantum confetti or hurl it into a time loop with no exit. Yet if a civilization, whether ours or another, learned to navigate this network, the implications are staggering. Distant epochs could become waypoints, history a roadmap, and the universe's first moments just a shortcut away. A primordial black hole network wouldn't just rewrite the rules of time travel. It would reveal that the cosmos has always had a backdoor. We just needed to mine the gravity. Dark matter has been the universe's silent enigma, an invisible force sculpting galaxies, bending light, and outweighing normal matter 5-1. But what if its role goes beyond just holding the cosmos together? What if dark matter is the universe's unsung timekeeper, the hidden anchor that makes time travel not just possible but stable? Think of spacetime as a vast, turbulent ocean. Without something to steady the waves, any attempt to navigate it would be like sailing a paper boat through a hurricane. This is where dark matter might come in. Its gravitational pull doesn't just shape the cosmos, it could be the counterweight that keeps time loops from unraveling. Wormholes, time crystals, even black hole tunnels theories abound for how time travel might work, but they all share a fatal flaw: instability. The moment you try to traverse them, quantum fluctuations or gravitational shear would rip the passage apart, unless, of course, something was holding it all together. Enter dark matter. Unlike normal matter, which clumps into stars and planets, dark matter forms vast, diffuse halos around galaxies, a cosmic net stretching across the void. Some physicists speculate these halos don't just influence space, they might pin down time. Picture a spinning top. Left alone, it wobbles and falls. But place it inside a stabilizing frame, and it stays perfectly upright. Dark matter could be that frame for time loops, its gravitational field smoothing out the wrinkles in spacetime, allowing hypothetical tunnels to remain open long enough for something or someone to pass through. The math behind this is startlingly elegant. Simulations of closed time-like curves, the theoretical pathways enabling time travel, show they collapse almost instantly under their own paradoxes. But when you factor in the gravitational influence of dark matter, something extraordinary happens. The curves stabilize, their chaotic fluctuations dampened by the extra mass. It's as if dark matter acts like a cosmic shock absorber, absorbing the chaos that would otherwise tear time loops apart. This could explain why we've never stumbled upon natural time tunnels. Without the right gravitational scaffolding, they'd flicker in and out of existence too quickly to notice. But here's the twist. If dark matter is the key to time travel, it might not be accidental. Some models suggest that advanced civilizations could engineer dark matter distributions, using it like a construction material to fortify their temporal highways. Imagine a far future society scattering dark matter particles along a desired path, creating an invisible rail system through time. To us, it would look like random cosmic scaffolding. To them, it would be the foundation of their greatest invention. Evidence for this might already be hiding in plain sight. Certain galaxies rotate faster than their visible mass should allow, a phenomenon traditionally chalked up to dark matter's gravity. But what if those anomalies aren't just about mass? What if they're signatures of engineered stability, places where dark matter has been tuned to support space-time structures we can't yet detect? Even stranger, some pulsars emit timing signals with inexplicable precision, as if their rhythms are being subtly corrected by an unseen hand. Could dark matter be the universe's silent clockmaker, ensuring certain cosmic mechanisms run smoothly enough to allow temporal tampering? Of course, skeptics argue this stretches dark matter's known properties to the breaking point. But that's the thing about the universe's greatest mysteries. They refuse to fit neatly into our boxes. If dark matter really does anchor time loops, it wouldn't just redefine time travel. It would reveal a cosmos far more cunning than we ever imagined, one that built its own safety nets, its own hidden doors, long before we even thought to look for them. And if that's true, the first time traveler might not be a person, but a force we've spent centuries overlooking, quietly weaving time's fabric in the shadows. Imagine the universe as a frozen lake. On its surface, everything seems solid, predictable, but beneath that thin layer of ice, there's a deeper, more volatile state waiting to be unleashed. That's the essence of vacuum decay, one of the most terrifying and strangely beautiful theories in physics. Our reality, according to quantum field theory, exists in a false vacuum, a metastable state that could, at any moment, collapse into a true vacuum, rewriting the fundamental laws of existence. And if that happens, time itself might not survive the transition. But here's the twist. What if this isn't just a random cosmic catastrophe? What if it's a tool wielded by time travelers to reshape reality itself? The math behind vacuum decay is as elegant as it is unsettling. In our current false vacuum, the Higgs field, the invisible energy field that gives particles mass, exists at a precarious energy level, like a marble resting in a shallow dip on a hillside. A nudge, however slight, could send it tumbling into a far lower energy state, releasing unimaginable amounts of energy as it falls. This wouldn't just be an explosion, it would be a redefinition. The speed of light, the strength of gravity, even the flow of time could emerge from the collapse with entirely new rules. A bubble of true vacuum would expand at light speed, erasing the old universe in its wake, leaving behind a new cosmos where the very concept of cause and effect might not exist as we know it. Now consider the possibility that this isn't an accident. A civilization facing the heat death of the universe, a slow, entropic fade into darkness, might see vacuum decay as their only escape. By triggering a controlled collapse, they could reboot reality, engineering the new laws to preserve their existence. Think of it like a programmer forced to rewrite an aging operating system. Sometimes the only way to fix the bugs is to start over. If time travelers from the future initiated this process, they wouldn't just be altering history, they'd be replacing it, crafting a universe where their survival is baked into the physics from the first instant. Evidence for this could be hiding in the fabric of space itself. Certain anomalies in the cosmic microwave background, regions where the temperature fluctuations don't quite match predictions, might be scars from previous attempts, aborted collapses that left faint imprints on the sky. Even stranger, some physicists speculate that dark energy, the force accelerating the universe's expansion, could be a sign of the false vacuum's instability, a slow leak in the cosmic dam that one day might burst. But the most unsettling question isn't whether vacuum decay is possible, it's whether we'd ever see it coming. A true vacuum bubble would give no warning, crossing the observable universe in a blink. One moment, everything is normal, the next, the laws of physics as we know them cease to exist. If time travelers triggered this, would they leave a message in the stars, a breadcrumb for civilizations like ours to decipher? Or would we simply vanish, our history erased like chalk from a slate, leaving no trace we were ever here? This theory doesn't just redefine time travel, it turns it into something far grander. The first time traveler might not be a person stepping into a machine, but a hand pressing the universe's reset button, forging a new timeline from the ashes of the old. And if that's true, the past, present, and future might be far more fragile than we ever dared to believe. What if the reason we've never found definitive proof of time travel isn't because it hasn't happened, but because someone's been meticulously cleaning up the evidence? Enter the Chronology Protection Agency, a hypothetical force from the far future tasked with one mission: ensuring the timeline stays intact by erasing every trace of unauthorized time travel. Think of them as cosmic librarians, silently reshelving the books of history whenever someone tries to scribble in the margins. This isn't just speculative fiction, there's eerie precedent in physics. Stephen Hawking's chronology protection conjecture suggested the universe might have natural safeguards to prevent paradoxes, like quantum effects destabilizing wormholes before they can be used. But what if those safeguards aren't just passive laws? What if they're enforced? Imagine a scenario where early time travelers, whether human or alien, left behind artifacts or messages in the ancient cosmos. A single misplaced object, like a futuristic tool embedded in a billion-year-old rock layer, could unravel causality if discovered too soon. The CPA's job would be to find and remove those anomalies before they're noticed, leaving behind only the faintest glitches in the cosmic record, the fingerprints of their cleanup. So where might these clues hide? Start with the WOW signal, that infamous 72-second radio burst from 1977 that's never been repeated. Mainstream astronomy chalks it up to natural phenomena, but what if it was intercepted mid-transmission by a CPA sweep team? Or consider the Tunguska event, the mysterious explosion over Siberia in 1908 that flattened 800 square miles of forest with no crater. Officially, it's blamed on a meteor, but witness reports describe strange lights maneuvering in the sky beforehand. Could it have been a temporal containment operation, scrubbing an errant time machine from history? The most tantalizing evidence might lie in the fossil record. Certain out-of-place artifacts, like the Antikythera mechanism, a 2,000-year-old device with gearwork rivaling 18th-century clocks, have long fueled speculation about lost ancient technology. But what if these aren't proof of advanced past civilizations? They could be CPA cleanup failures, fragments of future tech that slipped through the cracks before the timeline could be fully sanitized. Even the occasional disappearance of entire archaeological digs or unexplained data gaps in cosmic microwave studies might hint at something or someone working behind the scenes. Critics argue this theory is unfalsifiable by design. After all, the better the CPA does its job, the less evidence we'd ever find. But that's exactly what makes it so compelling. If a chronology protection agency exists, their success would be measured by our ignorance. Every historical inconsistency, every scientific anomaly we dismiss as coincidence or error could be their handiwork. The universe might be littered with the echoes of erased time travelers. Their stories were written so thoroughly that we'll never know they were here, the chilling implication. If the CPA is real, we may already be living in the version of history they've deemed safest, whether we like it or not. Black holes are cosmic riddles wrapped in gravitational enigmas, but their most perplexing feature might hold the key to time travel's oldest secret. The black hole information paradox, a decades-old puzzle in physics, asks a haunting question. When matter falls into a black hole, is the information it carries truly destroyed? Quantum mechanics says no, information must always be preserved. General relativity says yes, black holes erase everything beyond the event horizon. But what if both answers are right? What if the information isn't vanishing at all, just being moved not through space but through time? Think of a black hole like a cosmic shredder. Toss in a book and according to Einstein, it's pulverized beyond recovery. Yet quantum mechanics insists the words must still exist somehow. The resolution, some physicists argue, lies in the firewall paradox, a hypothetical inferno at the event horizon that burns incoming matter to a crisp. But here's the twist, that energy doesn't just dissipate. It could be encoded into Hawking radiation, the faint glow black holes emit as they evaporate. And if that radiation carries scrambled remnants of the original information, where does it go? The answer might be when rather than where. This is where time travel slips into the equation. If information is preserved through Hawking radiation, the process might not just be about encoding data, it could be relocating it. Like a cosmic fax machine, the black hole might be transmitting the information backward along the fabric of spacetime, depositing it in the past where it blends seamlessly into the universe's history. The lost data wouldn't be destroyed, just delivered elsewhere in time, like a letter slipped under the door of an earlier era. Evidence for this wild idea comes from the holographic principle, which suggests that all the information falling into a black hole is preserved on its surface, like a 3D movie projected from a 2D screen. If that's true, the information isn't trapped inside the black hole, it's smeared across its boundary, a swirling pattern waiting to be decoded. And if the hologram flickers, revealing glimpses of the past, it could mean the data isn't just stored, it's looping. The most tantalizing clue comes from quantum entanglement. Particles separated by a black hole's event horizon remain mysteriously linked, defying classical physics. Some theories suggest this entanglement might thread through time itself, stitching together moments across the black hole's life. Picture a pair of entangled particles, one falls in, the other escapes. The one inside could emerge in the past, dragging its entangled partner's state backward like a ripple in a pond flowing upstream. If that's happening, black holes aren't just cosmic dead ends, they're time-traveling messengers. Every particle they destroy might be a data packet sent hurtling into the past, subtly altering the universe's history without leaving a trace. The implications are staggering. Dark matter anomalies, unexplained quantum correlations, even mysterious fluctuations in the cosmic microwave background. could all be echoes of this interstellar postal service, where black holes are the sorting facilities and time is the delivery route. The paradox isn't a flaw in the universe's logic, it's a feature, a way for reality to ensure nothing is ever truly lost, just redirected. If we could unravel the code hidden in Hawking radiation, we might find more than just the ghosts of swallowed stars. We might find the universe's oldest time capsule, stamped with a return address we've yet to recognize: yesterday. The Boltzmann time traveler theory takes one of physics' most mind-bending thought experiments and twists it into something even stranger. Ludwig Boltzmann's original idea was radical enough. Given infinite time and space, random quantum fluctuations could spontaneously assemble anything: a fully formed brain, a starship, even an entire universe identical to ours. But what if those random fluctuations didn't just create objects or beings? What if they conjured something far more unsettling? A perfectly convincing illusion of time travel. Picture a Boltzmann brain, a self-aware entity that pops into existence by sheer accident, complete with fabricated memories of stepping out of a time machine. To this brain, the experience would feel utterly real. It might remember pressing buttons on a control panel, watching eras flash by, even meeting historical figures. Yet none of it ever happened. The brain's entire history, including its supposed journey through time, would be an elaborate fiction woven from chaotic quantum noise. This raises a chilling possibility. The first time traveler might not be a pioneer or scientist, but a cosmic mirage, a glitch in reality's coding that believes its own delusion. The statistics behind this are even more disturbing. In an infinite universe, Boltzmann brains should vastly outnumber real, biologically evolved observers like us. After all, it's infinitely easier for randomness to assemble a single conscious moment than to painstakingly build civilizations over billions of years. So if we accept that Boltzmann brains are possible, we're forced to confront an unnerving question. How do we know we're not one of them, hallucinating our entire reality, including the concept of time travel? Yet there's a tantalizing loophole. In the infinite dice rolls of existence, even the most improbable events must happen somewhere. What if a Boltzmann brain's false memories, by pure accident, aligned with real future events? Like a monkey randomly typing Shakespeare, the odds are astronomically slim, but not zero. A spontaneously generated time traveler could, by cosmic coincidence, carry information that later proves true. Imagine a Boltzmann brain appearing in ancient Rome, babbling about steam engines and electricity. To locals, it would sound like madness until centuries later, when its delusions became reality. This blurs the line between illusion and prophecy. If a Boltzmann brain's imaginary time travel somehow matched actual future discoveries, would that be mere chance or something stranger? Could the universe, through sheer statistical brute force, generate echoes of time travel that ripple backward without any real traveler? It's as if reality itself is running countless simulations, and occasionally one leaks through the cracks. The implications stretch beyond philosophy. If Boltzmann brains are possible, they could render evidence of time travel meaningless. Every artifact, every historical anomaly, even eyewitness accounts could just be flukes, random fluctuations masquerading as causality. A watch found in a medieval tomb might not be proof of future meddling, but a quantum accident, a momentary hiccup in entropy's march. But here's the twist that makes theorists pause. What if some Boltzmann brains survive? Most would vanish instantly, dissolving back into the void. But in an infinite multiverse, a few might persist long enough to interact with the world, leaving traces indistinguishable from genuine time travelers. Their false memories could inspire real inventions, their delusions sparking breakthroughs that shape history. In this light, the first time traveler might not be a person or an object, but a fleeting thought that refused to fade, a ripple in probability that somehow, against all odds, changed everything. The Boltzmann time traveler doesn't just challenge our understanding of time, It turns evidence into enigma. Every claimed sighting, every artifact out of place becomes a riddle. Is this proof of time's flexibility, or just the universe rolling dice in the dark? Either way, it forces us to confront the fragility of memory, perception, and perhaps even reality itself. The quantum Zeno effect sounds like something ripped from a sci-fi thriller. Ironically, it's one of the few time-manipulating phenomena that's been proven in labs. Named after the ancient Greek philosopher Zeno of Elea, who famously argued that motion is an illusion, this bizarre quantum quirk suggests that simply observing a system can freeze it in place. At the quantum level, particles exist in a haze of probabilities until measured like a spinning coin that only settles into heads or tails when you catch it mid-air. But here's the twist: if you measure that coin fast enough, over and over, it never lands. The act of observation becomes a cage, trapping the system in a single state. Now stretch this idea to cosmic proportions. The early universe was a seething quantum soup, where particles flickered in and out of existence in fractions of a nanosecond. But what if something or someone was watching closely enough to pin those particles in place? Under the right conditions, relentless observation could have carved out pockets of frozen time, microscopic bubbles where the universe's clock stopped ticking. These wouldn't be wormholes or black holes, they'd be still frames in the cosmic film, pauses so absolute that anything entering them might skip forward or backward when the freeze ends. Think of it like hitting pause on a movie. The characters don't vanish, they're just suspended, waiting for the play button to resume their story. In a quantum freeze, time doesn't cease to exist, it stacks up like unread pages in a book. A traveler stepping into one of these zones might experience seconds while millennia pass outside, or emerge in what feels like the past as the universe's delayed playback catches up. The eerie part: we may have already glimpsed this effect. Certain quantum systems in labs exhibit Zeno windows, where particles stubbornly refuse to decay under constant observation. Scale that up, and entire regions of spacetime could, in theory, be locked in similar stasis. But who or what could have done the observing to trigger this in the early cosmos? One possibility is as awe-inspiring as it is unsettling. The universe might have self-observed. In quantum cosmology, the act of measurement doesn't require a conscious observer, just an interaction that collapses probabilities into definite states. The Big Bang's extreme energy could have sparked countless such interactions, creating a cascade of Zeno freezes without any outside help. Alternatively, something else might have been watching. If advanced civilizations or even higher dimensional entities existed before our universe's birth, their mere presence could have nudged quantum systems into these frozen states, like a hand steadying a spinning top. The real magic lies in how these frozen pockets could be used. Imagine a spacecraft equipped with quantum sensors, designed to bombard a specific region of spacetime with enough observation to induce xenostasis. Step inside, and you're shielded from time's flow, a perfect way to survive interstellar journeys or leap across epochs. Even stranger, these zones might still linger today, hidden in plain sight. Dark matter's gravitational effects could mask them, or they might lurk near neutron stars, where intense magnetic fields mimic the conditions of the early universe. Of course, skeptics argue that scaling the quantum Zeno effect from atoms to astrophysics is a leap too far. Yet the underlying principle that observation shapes reality is already bedrock in quantum mechanics. Whether the universe's first time traveler was a frozen photon or an engineered Zeno chamber, one thing's clear: time might not be the relentless river we think it is. Sometimes it's just waiting for us to look away. What if time travel isn't about moving through the universe but stepping outside it entirely? The holographic principle, one of the most radical ideas in theoretical physics, suggests our three-dimensional reality might be a projection from a two-dimensional boundary at the edge of the cosmos. Like a movie playing on the surface of a vast cosmic screen, everything we experience, stars, planets, even time itself, could be pixels in an unimaginably vast hologram. And if that's true, then the key to time travel might not lie in wormholes or warp drives, but in finding a way to step off the projection, navigate the boundary, and re-enter the hologram at a different moment in its unfolding story. Think of it like editing a video. Normally, you'd scroll through the timeline to jump between scenes, but if you could access the raw footage, the data stored on the hard drive, you could rearrange it however you like. The holographic universe might work the same way. The boundary where reality is encoded could contain the entire history and future of the cosmos, written in quantum bits we can't yet read. A civilization advanced enough to decode and manipulate that data wouldn't just travel through time, they'd rewrite it from the source, bypassing the need for paradoxes altogether. The math behind this is both elegant and bewildering. Black holes, those cosmic shredders, taught us something revolutionary. All the information swallowed by their gravity isn't lost, it's smeared across their event horizons like data etched onto a cosmic DVD. Scale that up, and the entire universe might operate the same way. The AD/S/CFT correspondence, a cornerstone of string theory, suggests our four-dimensional spacetime could be fully described by quantum interactions happening on a distant, lower-dimensional surface. If that's true, time isn't a river, it's a playlist and the tracks can be reordered. But how would a boundary jump work in practice? Imagine a device that doesn't bend space-time, but disconnects from it like a cursor lifting off a touchscreen. By exiting the holographic projection, a traveler could navigate the boundary's timeless code, then re-embed themselves at a new point in the cosmic timeline. To observers inside the universe, this wouldn't look like a disappearance and reappearance. It would seem as though the traveler had always existed at the destination, their arrival seamlessly woven into the fabric of events. No paradoxes, no ripples, just reality quietly updating itself. Evidence for this might be hiding in the quantum realm. Particles entangled across vast distances instantly influence each other, defying the speed of light. This spooky action could be a glitch in the hologram, a sign that the boundary layer is processing changes faster than the projected universe can render them. Even stranger, certain anomalies in the cosmic microwave background patterns that look suspiciously like error correction codes might be artifacts of the universe's underlying data structure, hints that the projection isn't flawless. The most mind-bending implication: if time travel via holographic boundary jumps is possible, the first travelers might have left no trace at all. Their edits wouldn't appear as disruptions in our timeline, but as the subtle, unremarkable background of history itself. The people you pass on the street, the artifacts in museums, even the stars in the sky, some of them might not be original to this version of reality, but carefully placed insertions from a civilization that learned to rewrite the cosmos from the outside. This theory doesn't just redefine time travel, it turns the universe into a canvas, waiting for hands deft enough to paint outside the lines. And if those hands exist, they're not bound by the rules we know. They're working in the margins, where time is just another layer of code. Consciousness might be the universe's oldest time machine, not a device or a paradox, but the very act of observation itself. What if the first moment a being became self-aware wasn't just the birth of thought, but the ignition of a loop where perception bends time? This radical idea suggests that sentience doesn't arise within time, it creates it, weaving the past and future into existence through the sheer act of witnessing. Picture the universe before consciousness, a sea of quantum potential where every possibility exists at once. Without an observer, time might not flow in any meaningful direction, just a static tapestry of could be. But the instant the first mind flickers awake, whether in a carbon-based life form or an alien intelligence, that observation collapses the quantum fog into a concrete timeline. Like a projector switching on, the act of awareness stitches together cause and effect, creating the illusion of a linear past leading to the present. But here's the twist: that past might be a story the mind tells itself to make sense of the now, a narrative woven backward to justify existence. This isn't just philosophy, it's physics with fangs. Quantum mechanics insists particles exist in superposition until measured. Their history's ambiguous until an observer forces a choice. Scale that up to a conscious universe, and the implications are dizzying. The Big Bang's afterglow, the fossil record, even your childhood memories might not be artifacts of an objective history, but a retroactive construction shaped by present observation. In this view, the first conscious being didn't just perceive time, it authored it, drawing the arrow of time like an artist sketching backward from the finished painting. Evidence for this might hide in the hard problem of consciousness, why subjective experience exists at all. If consciousness were merely a byproduct of brain chemistry, why does it feel like anything to be alive? The time loop theory offers a spine-tingling answer, because feeling is the mechanism that generates time. Every qualia, the redness of an apple, the sting of salt, could be a tiny temporal anchor pinning reality into sequence. Ancient mystics spoke of the world as a dream. Physicists might call it a quantum waveform stabilized by sentient observation, the darkest implication. If consciousness creates time, then death doesn't just end a life, it unravels a thread of causality. Near-death experiences, where people report their lives flashing before their eyes, might not be hallucinations but the mind's desperate attempt to preserve its timeline before dissolution. Even black holes, those cosmic erasers, could be shadows of this principal, regions where the absence of observers lets time fray into meaningless static. Yet there's hope in the loop. If consciousness and time are entwined, then every new mind, born human, alien, or artificial, adds another stitch to the fabric of reality, reinforcing the universe's coherence. The first time traveler wasn't a visitor from the future, but the first spark of awareness, gazing backward and forward simultaneously, birthing time in its own image. And if that's true, we're not just passengers in time, we're its architects, dreaming the cosmos into existence one moment at a time. What if our understanding of time is like a fish trying to comprehend water, limited by only experiencing one layer of something far deeper? The meta-time hypothesis proposes that time isn't a single, linear thread, but a stack of dimensions, each folding into the next like the pages of an infinite book. In this mind-bending framework, the first time traveler wouldn't be a mortal fiddling with machines or cosmic strings. It could be a being from a higher temporal dimension, stepping into our timeline as effortlessly as we step into a room. Imagine a comic book character suddenly realizing their world is flat, printed on paper, and that a three-dimensional hand could reach in to move them backward or forward across panels. That's the essence of meta-time. Creatures native to these higher temporal layers wouldn't experience past, present, and future as we do. They'd perceive all moments simultaneously, able to navigate them like landmarks on a map. To them, our universe's timeline might look like a subway line with stops at the Big Bang, the rise of life, and the heat-death of the cosmos. Their version of time travel wouldn't involve paradoxes or wormholes, just the equivalent of choosing an earlier station on the route. This idea isn't pure fantasy. Some interpretations of string theory suggest the existence of up to 11 dimensions, most curled up too tightly for us to detect. If even one of these is a meta-temporal dimension, it could explain anomalies like déjà vu or precognitive dreams, glimpses of higher dimensional beings brushing against our timeline. Even quantum entanglement's spooky action at a distance makes eerie sense in this context. Particles might not be communicating faster than light, but diagonally across meta-time, bypassing our linear causality entirely. The most startling implication: our entire history could already be shaped by these higher dimensional visitors. Ancient myths of gods descending from the skies, modern UFO sightings, Even bizarre archaeological outliers like the 2-billion-year-old Oklo nuclear reactor might not be accidents or hoaxes, but footprints left by entities moving through time's hidden layers. Unlike the clumsy time travel of fiction, their interventions wouldn't leave paradoxes. Just as a hand pulling a fish from a river doesn't disrupt the water's flow upstream, meta-temporal beings could alter events without changing them because from their vantage, all versions of history already exist. Evidence for this could be hiding in plain sight. Certain mathematical patterns in the cosmic microwave background, like unnatural symmetries or geometric ratios, might be signatures of higher dimensional tweaks to our universe's code. Even dark matter's gravitational grip could be a side effect of meta-temporal structures pressing into our reality, like a thumb leaving dents in clay. Some theorists go further, suggesting that black holes aren't just cosmic vacuum cleaners, they are bleed-through points where meta-time leaks into our dimension, their singularities acting as temporary doorways. Yet the most haunting question isn't whether meta-time exists, it's why we're confined to our single layer. Are we stuck on the first floor of a temporal skyscraper, oblivious to the floors above? Or is our linear perception a safeguard, protecting us from the paralyzing overload of seeing time in its full, tangled glory? One thing's certain, if the meta-time hypothesis is true, then the universe's first time traveler wasn't breaking the rules. They were just playing by a deeper set we're only beginning to glimpse. From cosmic strings stitching time into loops, to Boltzmann brains hallucinating their own histories, we've journeyed through a labyrinth of possibilities where time isn't just a line but a kaleidoscope. Each theory we've explored, no matter how outlandish, cracks open a new window into the universe's strangest secret. That time might not be the relentless, one-way river we assume. Some paint time travel as a flaw in reality's code, others as a deliberate hack by future civilizations. Some suggest it's happening right now, invisibly, in quantum corners or dark matter's grip. And others, they turn time inside out entirely, proposing that the first traveler wasn't a being at all, but the universe itself folding its own origins into a loop. What's astonishing isn't just the variety, it's how each idea forces us to rethink everything. The holographic principle shrinks time into a projection on a 2D screen, while meta-time stacks it into unseen dimensions. Vacuum decay threatens to reboot reality entirely, and the omega point rewrites the past from the future's in-game. Even the failures like Hawking's chronology protection or Novikov's self-consistent loops reveal how fiercely the universe might guard its own rules. Whether time travel is a bug, a feature, or an illusion, one thing's clear: our universe is far weirder than fiction, so now it's your turn. Which of these mind-bending theories makes your neurons spark? Is it the black hole network weaving time's subway, or the chilling elegance of the Boltzmann mirage? Maybe you're convinced the CPA is out there, scrubbing paradoxes from history, or perhaps you're drafting your own wild hypothesis. Drop your thoughts below, and don't forget to subscribe for more cosmic mysteries. After all, the universe isn't done surprising us, and who knows, the next big time travel discovery might be lurking just beyond the edge of our understanding, waiting for someone, maybe you, to piece it together.